In this project, we want to illustrate how to make a part counter function block. We developed the function block in SCL for TIA Portal. Part counter, we need to define some variables for this counter. The first signal is reset. The next signal is the counting signal, and the sampling time of the cyclic interrupt block. It's around 100 milliseconds, and I consider it in seconds here. The output is part CNT. And the data type is double integer. The maximum value of double integer is more than 2 billions, and it's suitable for this application. We need to add some static. Edge memory for edge detection, 2 arrays, with 60 elements. Same for part counter. In a minute, we copy data, copy the objects that pass the sensor during a minute here, and we keep the number of objects passing the part counter in an hour here. It's a huge array of data. You can keep all gathered data during in each minute. In each minute, you save the number of passed objects, and you will have a great amount of data. You can calculate the mean value or anything you want in both data structure here. We need a loop counter in integer. And these are two integer variables. We need them to manipulate these two arrays. We need to know them because we increment these values, and we should know that in which array cell of counter minute values and hour values we are. These values are global values, and they are valid during the entire user program. Time calculation, we need something to measure the time in real format. And last mean and last hour to measure the difference, because we want to know the difference, how much object passed during this minute. And this is the last hour. After defining the parameters, the next step is developing the user program. The first part of the user program is the reset behavior. If reset is true, reset everything in the program. Reset everything calculated in the program. And we need to reset all the internal memories. Edge memory should be false, should be set to false. And these time measurement should be reset. It's a floating point value. And last min and last hour. Last min is equal 0, and last hour is equal to 0. And we need to use the for loop to initialize the array structures. Loop counter is I from 0 to 59. We want to reset the CNT minute, CNT minute, and CNT hour. Well, this part is the reset behavior. The next section is to develop the user program and how to measure how to count the passing objects and manufacture objects or something like that. We need the binary signal. This is our binary signal. If this binary signal is true, we need a positive edge. For positive edge, it's possible to use the function block that is available for positive edge in the instruction library or instruction set for S7-1500. We can use the easier version here. We will make our own positive edge detection block. In case of positive edge, we need to increment CNT internal. We should add this CNT internal here. CNT internal as a double integer, we need to increment this. And it should be in the initialization part. We increment. The next step is to make this memory true, because we want to have a short pulse. So we have a positive edge here. The next step is to copy the result of the counter. Copy the result of the counter to the output. The result of the counter is CNT internal. We make a copy. The next step is to equalize this edge memory with the pulse input signal and time measurement. Use a simple incrementation to increment the accumulated time value, and we need to add 100 milliseconds in each cycle of the CPU. Now we compare the measured time. This parameter is measured in seconds, value in seconds. If this value is more than more than 60, it means that we pass the first minute. Sixty seconds. When we pass the 60 seconds, it means that 1 minute is passing, and here we should do some value. We should copy some values here. CNT internal minus last minute. We increment the X value to move to the next cell, and put the measure time to 0. Reset the measure time. It's a floating point value. The next step, if we pass this condition is met when we pass 1 minute, but in case of we passing 60 minutes and it's around 1 hour, what will happen? if x is the value, we keep to monitor the amount of minutes are passing. It's a variable to control the array that keep the values for each minute. If x is more than 59, it means that 1 hour is passing. We need to CNT hour in the hour array is controlled by y is equal to CNT internal minus last hour just note that we need to copy hour. We need to copy the last part counter into the last hour. We should do it here, and we need to do it here, because in each cycle we should update this value last minute. We should update these values. We need to increment y should be incremented. We need to initialize x, and in case of we pass 59 hours. In case of y is more than 59, if y is more than 59, it means that 59 hours passing. We need to reset x to 0. This should be a redundant writing, and y also should be set to 0. And it's done. Let's check the whole program again. This is the reset part, and all arrays are reset when the reset signal is true, and we didn't put the else here. We need the else. We need the else here. If reset is not true. If reset is not true, we need the counting copied to the output memory. Positive edge memory is equalized with the input signal. Time value is incremented if time value is more than 61 minutes is passing. We copy the value for the first minute, equalize this register with the available counted object, increment x, and we reset the timer, and we need to start counting the minutes. If the number of minutes is more than 59, we need to copy the accumulated values to the counter the array cells that we set aside for our hourly counters. Same here, we increment y is keeping the number of hours, and if the number of hours passing 59, we reset everything. Let's function test the program. Before that, we need to call this FB1 in OB cyclic OB30 with 100 ms. We insert the FB here, and let me check if it's possible to insert some other networks. I need to add the counting M100 as 0 as reset, and M101 as M101 as the pulse, and keep the sample time to 100 ms. Reset signal should be changed here to reset, and the CNT should be changed to pulse. And here we need to insert an STL for this pulse signal. So call to pulse. And we have the pulse signal. For the reset signal, we need to initialize the reset signal in OB100, the start of OB reset. Set is a call to reset. Compile the whole program, and we need to download it to PLC SIEM. And now download. Let's check the part counter DB, go online. Let's see if it's possible to set. So maybe we change the mode from stop to run. The reset signal is true, and we can change the reset signal to false and function test. Let's change that on the memory. We need to change the memory. Let's see what's happening. The part counter is moving, and the actual time measurement is actually 17 seconds, 18, 19, 20 seconds, and the part counter is counting here.